everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be discussing Chapter 2, Section 2, Point-Slope Form. The point-slope form of an equation looks like the following. Y minus y1 equals m times x minus x1, where m is representing your slope because that is the universal variable for slope. And then on this form we're also given a point. That point is found by using the x1 and y1 value of the equation. And we're going to look in detail about how we write the points and slope from this equation. So our first example is to identify the slope and one point on the line y minus 3 equals 1/3 times x minus 2. So if you recall from the previous slide, point slope is y minus y1 equals m times x minus x1. So when we are asked to identify the slope, we need to match up the slope in the equation. So the slope is always the number after the equals and in front of the parentheses. In this case, the number after the equals and in front of the parentheses is 1/3. So the slope of this line is 1/3. Now, as for the point is always written as x comma y because a standard pair is xy. So what we want to do is we want to look at what number is after the x to figure out our x value and what number is after the y to figure out our y value. So if we take a look after the x, you have a 2. Now you might think it's a -2, but there was already a minus in the original equation. So when we write the point, we're actually going to write the opposite sign of what we see. So while it looks like a -2, we're going to say that this is +2. And the y value, what's after y, it looks like a -3. We're going to say that's a +3. So we will say the point of this line is at 2, 3. So now we want to take that same equation we were just working with, y minus 3 equals 1/3 times x minus 2, and we want to write it in slope-intercept form. So if you recall, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So what we're going to do, we're going to get the y all by itself by solving this equation. But first, we need to distribute on the right-hand side to get rid of the parentheses. So I'm going to distribute the 1/3 to have 1/3 x. And then I also need to multiply the 1/3 with 2. So I'm going to put the 2 over 1 since 1/3 is a fraction. And I'm going to multiply straight across. 2 times 1 over 3 times 1. So I have 1/3 x minus 2/3 on the right. On the left, I'm just dropping down y minus 3. So I'm starting to see y equals mx plus b. However, there's a -3 with the y that I need to get rid of. So think about when you solve an equation. If something's being subtracted, we do the opposite and we add that something to both sides. So I'll be left with y equals, I'm going to drop down the x term, 1/3 x. But then I have to figure out what -2/3 plus 3 is. So over here to the side, -2/3 plus 3. I'm going to make 3 a fraction by putting it over 1. And then I need common denominators, which would be 3 between 1 and 3. So 1 times 3 gives me 3. 3 times 3 is 9. And if I add these together, that's going to give me a y-intercept at 7/3. So when I put this equation from point slope back into slope-intercept form, I can easily see the slope is 1/3 and the y-intercept is at 7/3. So using all this information from the 2 previous problems, we are going to graph our equation y minus 3 equals 1/3 times x minus 2. So in our first problem, we said the slope of this line was 1/3, and there is a point at 2, 3. This is the same problem we started with. And in the second problem, we just said in slope-intercept form, this would be y equals 1/3 x plus 7/3. So what we had been doing, we had been starting by graphing our y-intercept, 7/3. But I don't know about you, but graphing 7/3 does not sound like fun. So what we're going to do, we're going to play on the fact that we know a point and we know the slope of the line to graph this line rather than worry about plotting a decimal or a fraction. So I'm going to start by plotting a point at 2, 3. Because my equation says there's a point at 2, 3. And then from there I'm going to count my slope. Rise 1, run 3. So up 1, right 3. And count it one more time to get 3 points on this graph. So I've got my 3 points on the graph. What I'm going to do now is connect them in as straight of a line as possible. And what I want to do, once I graph it, I kind of want to verify my y-intercept is pretty close to where it should be. Might not be perfect because, you know, I didn't use a ruler to draw this line. But my y-intercept is at 7/3. Well, 3 goes into 7 twice with a little left over. If I take a look, comparing my y-intercept, I'm around 2. So that is in a close enough location for a guesstimated sketch of a graph. So as you can see, the y-intercept, the point, and the slope all come into play when you graph the line. So now we're going to repeat this process, but we're going to do it with a different equation. So we're going to start by identifying the slope and one point on the line, y plus 2 equals 1/2 times x minus 3. So when I start this, my slope is always the number after the equals, but in front of the parentheses. In this case, that means my slope is 1/2, because that's the number after the equals and in front of the parentheses. My point then comes from the numbers with x and y, but remember we're going to do a sign change on those numbers. That's the trick, is remember to switch the sign when you identify a point. So with x, you see there's a 3. It looks like a -3, so that means it's actually positive. And with y, there's a +2. So it looks like a +2, but it's actually negative. So we have a slope of 1/2 and a point at 3, -2. So now we're going to take that equation, y plus 2 equals 1/2 times x minus 3, and write it in slope-intercept form. So we want y equals mx plus b. So what I'm going to do is draw a line down my equals, and I'm going to solve this equation for y. But before I try to get y by itself, I always do my distribution first. So 1/2 times x would be 1/2 x. And then 1/2 times 3. Well, I just need to make 3/1 and multiply straight across. So this would be minus 3/2. Then I'm going to drop down y plus 2. And now I need to get y by itself, so I have it in slope-intercept form. Y equals mx plus b. Right now, the only thing standing in our way is the +2. So we're going to need to subtract 2 on both sides of our equation. So we're going to have y equals, drop down the 1/2 x, but then we actually need to figure out what -3/2 minus 2 is. So I'm going to start by putting the 2/1, so I have 2 fractions, and then I'm going to get my common denominators, which in this case would be 2, because 1 and 2 both go into 2. So you multiply by 2, so that makes a new numerator of 4. -3 minus 4 is -7/2. So in slope-intercept form, this point-slope equation would read y equals 1/2 x minus 7/2. So that tells us we still have a slope of 1/2. That shouldn't change. but now we have a y-intercept at -7/2. Again, something that's not super friendly to graph, which is why we're going to rely on our point and slope to do it. So we're going to graph this equation we've been working with. Y plus 2 equals 1/2 times x minus 3. So we already said there's a slope of 1/2 and a point at 3, -2. And we said that in slope-intercept form, this would be y equals 1/2 x minus 7/2. So while it would be wonderful to start graphing at -7/2, our y-intercept, it's just not super friendly to graph at a decimal. So what we're going to do instead, we're going to start by plotting our point and our slope. So our point is at 3, -2. So we're going to go to 3, -2 and plot a point. And then from there, we're going to count our slope. Rise 1, run 2. So up 1, right 2. Up 1, right 2. Once we have that connected, we're going to make our line, putting arrows at the end. And then we're just going to think, does our line cross the y-axis at the number it's supposed to? Well, if we take a look, y-intercept was -7/2. 2 goes into 7 3 times with 1 left over, so that'd be around -3.5. If we look at our graph right there between -3 and -4, we cross the line. So we are right around where we should be. So again, the point, the slope, and the y-intercept, all three factors affect what's happening in your graph. You should always see your y-intercept around the right spot and your point around the right spot. The slope is telling you how slanted the line is. So now I want to identify the slope and one point on the line, y equals 3/4 times x minus 3. So what we're going to do is first identify our slope. Slope again is always what's after the equals, but in front of the first parentheses. So in this case, our slope would be the fraction 3/4. Our point is always written x and then y. So what we're going to do is find x and see what number's with it. In this case, it's a -3. So even though it looks negative, remember points, we do the opposite sign. So this one would be positive. And then think about what's with the y. There's nothing on that side with the y. So if there's nothing there, what number represents nothing? That would be 0. So the point's 3, 0. The slope is 3/4. So now we're going to take that equation and we're going to write it in slope-intercept form. So what we want to do is start by distributing the 3/4 on the right-hand side. 3/4 times x would be 3/4 x. And 3/4 times 3, I've got to put the 3 over 1 since there's a fraction involved. And then 3 times 3 is 9. 4 times 1 is 4. So I have 3/4 x minus 9/4. If I drop down the y on the other side, I have y equals 3/4 x minus 9/4. This one's already in slope-intercept form at this point because there was nothing else with the y. So I can see my slope matches, it's still 3/4, and my y-intercept's at -9/4. So now we're going to take this final equation we've been working with and graph it. So just to review, we first found that there was a slope of 3/4 and a point at 3, 0. And then the slope-intercept form told us y equals 3/4 x minus 9/4. So we could plot the y-intercept, but plotting at a decimal again is no fun. So what we're going to do instead, we're going to use our point and the slope to make our graph. So we're going to plot a point at 3, 0. And then we're going to count our slope. Up 3 over 4. And I can go up 3 again, but I can't go right 4 again. So if I reverse this from my original point, I'm going to go down 3, left 4. Connect these to make a line. And what I should notice is that the y-intercept should be falling close to where I free drew my graph. So 4 goes into 9 twice with a little bit more. This is between -2 and -3, so it's close enough to where we need it. So again, point, slope, and y-intercept, all of them affect how the graph looks. This concludes our lesson on Section 2, Point Slope Form. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.